Oh, Andrew soup.
Okay, so in today's lesson, we're going to talk about the 5 key data points that we use to make a box and whiskers plot. We're going to create the box plots. We won't do much with number 3 today. That's interpreting and comparing box plots. That's more what we'll be doing tomorrow. So the first 2 objectives are the things we will be doing today. Okay, so the parts of a box and whisker plot. Box and whisker plot looks roughly like this. This part is the box, and you should label these on your notes as I do. And then the things sticking out on the sides are the whiskers. So this is a whisker. You have a whisker over on the other side. And each part of this box and whiskers tells us about a different thing. We put a dot at the end of the lowest whisker. That dot stands for what's called the lower extreme. So when we have a set of data, our lowest number is just the lowest extreme. We're going to put them in order, just like we did when we found median, and that's where we'll put the lower extreme. Question?
Is the line in the middle of the box the median?
Yes, we'll get there. Okay, the first line, actually, let's start with this middle line. This middle line is the median. So when we put our numbers in order, it's that middle number. And then the dot at the top is called the upper extreme. That is our biggest number in our data set. The numbers represented by the sides of the box are special numbers too. This one is called the lower quartile. And we'll talk about what the lower quartile means in a minute. Lower quartile is basically we're taking the bottom half of the data from the median to the left, and we're finding the middle of that set of data. So it's like the median of the bottom part of the data.
Wait, this thing's complicated.
This line is for the upper quartile. The upper quartile is if we take all the data from the median up to the highest, it's the middle number in that half of the data. And we'll take a look at an example. You'll get to see how this works. Okay, some other things that you need to know about this is that each part of a box and whisker plot represents 1/4 of all the data. So from the lower extreme to the lower quartile is 25% or 1/4 of the data. From the lower quartile to the median is the next 25%. From the median to the upper quartile is the next 25%. And from the upper quartile to the upper extreme is the last 25%. So it's just a way of splitting the data into 4 parts. Each part, no matter how big it is, contains the same amount of data. So you might have a box and whisker plot that looks like this. You might have something like this. From the lower extreme to the lower quartile, to right here, is 25% of the data. When it's longer, it just tells us more how the data is spread out. So longer parts of the box plot means that the data is more spread out. So box plots, I'm going to erase this box plot that I just drew so I can write some more information on here. Box plots show how much variability is in the data. So box plots show variability. What measure have we learned about that also shows variability? We have mean, median, mode, and range. Which one of those shows variability? Raise your hand. Andrew? The range. The range shows variability. And the range is just, on a box plot, it's just the difference between the upper extreme and the lower extreme. Because the range is the difference between our biggest number and smallest number. So on a box plot, that's just the difference between upper and lower extremes. And then there's something else that we determine from a box plot that's called the interquartile range. The interquartile range is just how far it is from one end of the box part to the other. So the interquartile range, and then I'll get out of your way here so you can see. Interquartile range is the difference between the upper and lower quartiles.
Oh, no,
Upper and lower quartiles. Okay, I'll give you a second to finish writing all this stuff. Okay, so here's how we make a box and whisker plot, and I've given this to you step by step so you know what to do. Here's our data set, our list of numbers. The first step is always to list the numbers in order, just like we do whenever we're finding the median. So putting these numbers in order, my smallest number is 11. When I put numbers in order, I cross them off as I go to make sure I don't skip any. Next, I have 112. So I'm going to write 12. Cross that off. I have a 13. I have a 14. I have a 15. I have a 16. There's no 17, 18, 19. I have a 20. I have a 22. And I have a 25. The other thing I always do when I put numbers in order is I count how many I had before and I count how many I had afterwards. So I go 1, 2, 3, 4, 5, 6, 7, 8. I had 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 numbers. That way I'm sure that I did not skip any numbers, because if you skip one, all of your answers are going to be wrong and you'll miss everything. Okay, next thing we do is we find the 5 key data points. The lower and upper extreme are really easy to find. What would the lower extreme be? Andrew? 11 is the lowest number. How about Travis? What's the upper extreme?
Upper extreme would be 25.
25, good. Median we also know how to find. Jenna, what's the median? 15, good. Now, to find the lower quartile, what we do is we're going to use the median to cut our data in half. So I'm going to draw a line right here. That's our center. So I'm not going to use the 15 because it is the median. So I'm going to take the data on this side of the 15, and I'm going to take the data on this side of the 15, and I'm going to use that data to find my upper and lower quartile. My lower quartile is just the median of just the bottom half of the data. So I'm finding the median of these numbers. Jace, what would the median of those numbers be?
20, 25, 20.
No, of the numbers I have circled in red. What number's in the middle?
No, don't you have to add 12 and 13 up?
You do, yeah.
Yeah.
That's what
so
you're doing.
25 and then divided by 2, it'd be
Like number.
that'd be like 14.5 maybe.
Jace, think about which number comes exactly in the center of 12 and 13.
12.5.
12.5.
We got a cheat over here.
12.5.
Know something.
I just want to know what the homework was. I just
Okay. Then the upper quartile, we're going to look at the top set of data. So we're going to look at this half. Caleb, what would my upper quartile be?
21.
21, good. It's the number right in between 20 and 22, which is 21. Okay, so once I find my data, now I make the box plot. The lower extreme is just a dot, and the upper extreme is just a dot. Let's see, upper extreme is 25, so that's here. We always use a number line that has evenly spaced values. So you can't just put these numbers on the number line. You have to draw a normal number line. The median gets a line. The lower quartile gets a line. So 12.5 is going to be halfway between 12 and 13. Upper quartile gets a line. So everything gets a line except the upper and lower extremes. We put a dot there. You connect the 3 lines to make your box. And then you extend outward to your whiskers.
And you can't
Okay, any questions about how to do this?
Nah.
On the next slide, there is a data set for you to try making a box and whisker plot from. Okay, so let's go on to that.
It's gone.